Have you ever really stopped to consider a microSD card? Held one in your hand and truly appreciated what it is? It's tiny, smaller than a postage stamp, a marvel of miniaturization. It's hard to believe something so small can be so powerful. Yet it can hold thousands of photos, entire music libraries, or hours of high-definition video. Think about that for a moment. All that data, compressed and stored on something you could easily lose in your couch cushions. How does something so small store so much? What's the secret? What kind of technology makes this possible? Today we're going to find out. We're going to demystify this tiny titan of data storage. We'll peel back the layers and see what's inside. No magic, no smoke and mirrors, just pure, elegant science and engineering. Think of it as a high-tech treasure chest, a vault filled with your digital memories and important files. Simple on the outside, unassuming, but packed with intricate mechanisms, complex circuits and cutting-edge technology inside. It's a testament to human innovation. These cards are everywhere, ubiquitous in our modern lives. Phones, cameras, the devices we use every single day. Drones, game consoles, and countless other gadgets rely on these tiny storage solutions. Quietly storing our digital lives, safeguarding our precious data. Let's grab our virtual magnifying glass, our digital microscope, and dive into the fascinating world of the microSD card. We're about to go on a journey to the heart of this technology. We'll explore its tough outer shell, the protective layer that keeps the delicate components safe, the golden pins that connect it to the world, allowing data to flow in and out, and the circuit board that holds it all together, the foundation upon which everything else is built. Then, we'll meet the two stars of the show, the key players in this technological drama. The controller, the brains of the operation, the traffic manager, and the NAND flash memory, the workhorse of data storage. The library where your data lives, carefully organized and readily accessible. It's a story of miniaturization pushed to its absolute limits, cramming billions of electronic switches, transistors smaller than a virus, into a space you can balance on your fingertip. It's truly mind-boggling. This would have seemed like science fiction, an impossible dream, just a few decades ago. The progress we've made is astonishing. So, get ready for a journey, an exploration into the inner workings of this ubiquitous device, into a world almost too small to imagine, a realm of atoms and electrons. By the end you'll see that little black rectangle, that seemingly insignificant piece of plastic, as a masterpiece of human ingenuity, a triumph of engineering and design. You'll understand the clever physics, the fundamental principles that make it all possible, and engineering that let it capture your memories, preserve your experiences and store your favorite moments, keeping them safe for years to come. Let's crack open the case, virtually of course, and see what's just beneath the surface. Prepare to be amazed. Spoiler alert. It's way cooler than you think. Get ready to have your mind blown by the incredible technology packed into this tiny device. Let's start with the outside. We often take these tiny marvels of engineering for granted, but there's more than meets the eye when it comes to a microSD card. The black plastic shell isn't just for looks, it's the first line of defense. It's tough epoxy resin, carefully molded to withstand the rigors of daily life. This isn't your average plastic, it's protecting the delicate electronics from dust, moisture and drops. Think of it as a tiny fortress for your precious data. It's designed to be resilient, ensuring your data remains safe even in challenging environments. Flip it over and you'll see the golden stripes, shimmering against the dark background. These are the electrical contacts or pins, the gateway to your device. Usually 8 of them, precisely arranged and meticulously crafted. They're the only way the card communicates with your device, acting as the vital link for transferring information. Without these, the card would be an island, unable to share its contents. Each pin with a specific job, a designated role in the complex dance of data transfer, power, data, and control. Each one essential for the card to function correctly. They work in perfect synchronicity. Gold plating ensures a reliable, corrosion-free connection, guaranteeing longevity and consistent performance. It's a small detail that makes a big difference. Beneath the shell and pins is the printed circuit board, or PCB. It's the foundation for all the internal components, the bedrock upon which everything else is built. The PCB is a network of fine copper pathways, intricate and precise, connecting power and data between the pins and the chips. These pathways are the veins and arteries of the card. It's a marvel of miniaturization, a testament to human ingenuity, ensuring every signal gets exactly where it needs to go, with minimal interference and maximum efficiency. So before we even get to the chips, the real brains of the operation, we already have a compact, robust design, a carefully engineered package. The shell protects, the pins connect, and the PCB ties it all together, creating a seamless and efficient system. Every millimeter has a purpose. Every component plays a vital role, working in harmony for reliable storage, ensuring your data is always accessible when you need it. Now let's meet the real stars, the components that truly define the capabilities of this tiny device. The chips that do the heavy lifting, the memory and the controller, working tirelessly to store and manage your data. Ready? Let's go inside and explore the inner workings of these fascinating components. Inside the controller chip is the brains of the operation, the CEO of the microSD card. When you save a photo, your device talks to the controller, not the memory directly. The controller manages where data is stored and how it's retrieved, translating requests into actions the memory chip understands. It handles wear leveling, spreading data evenly so no single spot wears out too quickly. It also manages error correction, using algorithms to detect and fix tiny data errors before you ever notice. Without the controller, the card would be unreliable and short-lived. It's the unsung hero, making sure your files are safe and accessible. So while the memory chip gets the glory, the controller makes it all possible. Next, let's look at the memory itself, the NAND flash chip. Imagine a vast warehouse stretching as far as the eye can see. The NAND flash chip is essentially that warehouse, a digital repository where all your precious data lives, breathes, and waits to be accessed. It's the heart of your storage. It contains billions, an almost unfathomable number, sometimes trillions, of these tiny compartments, of microscopic memory cells, each meticulously crafted and arranged, each one storing a 1 or a 0, the fundamental building blocks of all digital information. Unlike RAM, which needs constant power to hold data, NAND flash is non-volatile, meaning it remembers even when the lights go out, so your data stays put even when the power's off. It's like writing in permanent ink, rather than on a whiteboard that wipes clean. This is perfect for portable storage, where power isn't always guaranteed. Your photos and videos are safe for years, preserved and ready to be shared whenever you want. The memory cells are arranged in a grid, a structured layout that allows for efficient access and management. These grids are organized into rows called pages, the smallest unit of data that can be written at once. And groups of pages are called blocks. Think of blocks as chapters in a book, each containing multiple pages of information. You can write data one page at a time, filling up the pages with your digital content. But to change data, you have to erase an entire block first. It's like needing to clear an entire chapter to make even a small correction. This erase before write quirk is a fundamental characteristic of NAND flash memory. This is why deleting files doesn't always free up space instantly. The system marks the block as available, but the actual erasure happens later. The controller juggles data, acting as a librarian, organizing and managing all the information, moving it around to keep things running smoothly, optimizing performance and extending the lifespan of the flash memory. It's a constant high-speed game of digital Tetris, fitting data into available spaces and preventing fragmentation, all behind the scenes, a complex dance of algorithms and hardware working in perfect harmony. This teamwork between controller and NAND flash is a critical partnership, each component relying on the other, is what makes dense, reliable storage possible. How does a memory cell hold a 1 or 0 with no power? Enter the floating gate transistor. Imagine each cell as a tiny hotel room with a door that traps electrons inside. To write a 0, the controller uses high voltage to push electrons into the floating gate, where they're trapped. An empty gate is a 1, a full gate is a 0. Reading the cell is just checking if the gate is full or empty by measuring current flow. This happens millions of times per second across billions of cells. Forcing electrons in and out wears down the cell over time, limiting write cycles. But it's a genius way to store information, trapping electrons to create a permanent digital record. It's physics at its most practical and impressive. Early flash memory stored 1 bit per cell single-level cell, or SLC. Simple, fast, and durable, but expensive. To boost capacity, engineers created multi-level cell, or MLC, storing 2 bits per cell by measuring more charge levels. Then came triple-level cell, TLC, and quad-level cell, QLC, packing 3 or 4 bits per cell by distinguishing even more charge levels. This is how we get huge capacities in tiny cards. The trade-off? More bits per cell means slower speeds and less durability. SLC is used for high-endurance cards. TLC and QLC are common in consumer cards for their balance of cost and capacity. More levels mean more storage, but also more stress on each cell. For most users, TLC and QLC offer plenty of space at a great price. That's the secret behind affordable, high-capacity microSD cards. How does your device talk to the card? Through protocols like languages for data. The main ones are SPI, older slower, and SD mode, modern fast. SD mode is standard for today's devices, defining how data is sent and received over those golden pins. Speed classes, like Class 10, UHS, and Video Speed Class, guarantee minimum write speeds. Class 10 means at least 10 MB per s, U3 means 30 MB per s, crucial for smooth 4K video recording. Video Speed Class, V30, V60, V90, is for even higher resolutions. Application Performance Class, A1, A2, measures how quickly the card can handle lots of small random data, important for running apps. These ratings ensure your card matches your needs, whether it's for video, photos, or apps. Storing data is one thing, keeping it safe is another. Error Correction Code, or ECC, is a digital safety net. The controller writes extra data alongside your files, checks it on read, and fixes small errors automatically. Where leveling spreads out writes, so no single cell wears out too fast, extending the card's life. Bad block management marks faulty memory blocks as unusable, both at the factory and as the card ages, remapping data to healthy blocks. All this happens invisibly, making your card far more reliable than the raw memory alone. These silent systems are why your files stay safe, year after year. So, how does so much fit into something so small? It's a symphony of engineering. From the tough shell to the quantum-level memory cells, every part is a clever solution. The controller manages data, corrects errors, and extends the card's life. The NAND flash chip stores billions of bits, using physics to trap electrons as information. Protocols and speed classes ensure your data moves quickly and reliably. Behind it all, silent systems keep your files safe and sound. It's a self-managing, self-healing ecosystem, smaller than your fingernail. Next time you use a microSD card, remember, you're holding decades of innovation and a true engineering marvel. 10.